Hello, everybody, live and also people on YouTube. Thank you for coming. A few things to mention. This Thursday with Patrick Schwabel, we're going to talk about measuring political positions using contextual word embeddings. So NLP in the political and social sciences. And the week after that, we're going to have a live get-together for all women in the field of NLP who wish to do some live mentoring, do some networking, just a get together for both events and all future events. You can check out the Discord channel. We keep everything up to date there. I would also like to say a few general words for people listening that are potentially coming from outside the field of NLP. With the arrival of the so-called attention mechanism and its usages in the transformer models architecture, which is state-of-the-art in not only NLP, but most fields in using machine learning. The field has been progressing exponentially. Something that gained international and just general traction was GPT-3, which was a generative model able to generate high-quality text, but it was not free, it was not open source, and it was not as interactive as, say, ChatGPT. And this is just to come to the point that with ChatGPT being released in November, this type of technology left the realm of AI and NLP and became everybody's problem. And with all of its challenges and positives and everybody's work and personal life. And of course, it has already made its way into different domains. For example, the legal justice system. And this is exactly what we're going to talk about today. So Shanshan Xu, who made her finish her PhD, bachelor's and master's in LMU Munich, is currently a PhD student of LegalTech in the Technical University of Munich, and she's going to talk about the genuinely really interesting subject of legal judgment prediction models and their misalignment with actual human legal experts. So thank you, Shanshan, and you can share your screen. Thank you.
Okay. Thanks for having me here. So let me share my screen. Okay. Okay, I hope you can see my screen now.
Yes.
Okay, great. So, yeah, I'm Shanshan. I'm a PhD student at LegalTech now. Before that, I studied linguistics at LMU. So, I guess, okay, so wait a minute. Okay, I would guess for most of people, like LegalTech or NLP, legal NLP is unfamiliar to you. So first, I will give you an short introduction about legal NLP, and then I will introduce more about our research on the deconfounding legal judgment prediction model for better alignments with expert. Okay, but before I start to talk, I want to do a short advertisement here. So I'm organizing this Women in NLP event on 21st April. And we are very honored to have Professor Barbara Planck as a panelist, as well as Anita Green, she's a director at Microsoft, as well as Claudia, she's the co-founder of Convalet. And the Convalet is generously provide us with a very nice location and also drinks and snacks. So, and also I'm very grateful Munich NLP helped me to do the online promoting. So if you are interested, please scan the QR code and sign up. So I look forward to meeting you there. Okay, so come back to LegalTech. What is LegalTech? What do we do in legal NLP? Basically, we want to build a bridge between these two domains. One is law, where the lawyers tend to think in like knowledge or concept symbols, where the other side is, of course, machine learning, where the computer scientist or data scientists tend to think in data as numbers as statistics. And of course, with the development of the latest technology, NLP, machine learning. So people are trying to solve law problems with machine learning. However, there are still many problems unsolved and seems to be quite difficult for machine learning. Why? So here is an example. For example, I have legal case retrieval tasks. However, the query in natural language can look like this, like give me all decisions by the Federal Court of Appeals for veteran claims where a plaintiff, blah, 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 and so on. So as you can see, the legal language is very different from the language in general domain. The quirks, the difficulties here are like, for example, legal language often includes multi-actors and multi-opinions, and there are statements about statements, and also includes the domain-specific lexicons. So maybe as you have already experienced as even as a native speaker, you read a legal text in your language, it might be even sometimes difficult for you to understand it because of these legalese. Another difficult part for machine is, for example, the citations. So in law text, they have even more complicated citation system than in scientific writing. I will show you an example later. And also is the other problem is the long document. Currently, the transformer model, let's say BERT or beta, can take around 500 tokens. The long format takes around 4K. ChatGPT takes also about 4K. However, in legal domain, the text can easily get longer than 10K or even 20K. So how to solve this problem is a difficulty here. And the other one is data set. Unlike in general mainstream NLP, you can get labeled data set via crowdsourcing. In legal domain, you need experts to label it, which is of course much more expensive. So another very big problem is the explainability. So nowadays, these pre-trained large language models, they are like black box. So, but in such a high stake domain like legal, if any decision process is going to be made by these kind of systems, it's very important for the model to not only be correct, not only be right, but also right for the right reason. So explainability plays also a big role here. And here is an example of legal text. So it's just a chunk from the case. The original text is much longer, and here only the gray text are the normal input, the normal text. The colorful one, the red one are the citations. As you can see, it contains the case name, applicant's name, dates, folder name, and so on. And the purple ones are the holdings, which specify why this case is cited or something like this. And then, of course, in legal domain, or people are trying to use the latest technology. For example, this text is generated by GPT-2, and we can see here it looks like great. You read it, it makes sense, and it cited some cases, very well formed. However, if you look deep into it, it's nonsense because the case it cites here doesn't exist. I think that's quite normal. Like a phenomenon observed by those large generative model. It's a hallucination, and it's not only in GPT-2. In ChatGPT, this problem still exists. As you can see here, if you ask ChatGPT to recommend you some case to cite, it gives reasons. It reasons quite well. But if you look at those cases, the form looks good. But however, obviously these are those cases doesn't exist. That's the hallucination. So I think in our post online, because we used a quite catchy titles, right? Will lawyers be replaced by ChatGPT? So the short answer is not yet. Okay, so let's come back to academia. What are we doing in legal NLP in academia? The research tasks is actually quite similar to in the mainstream NLP. For example, prior case retrieval, it's a classical information retrieval task, document retrieval, and the summarization. But in legal NLP, of course, the difficulty is the length of the document. So how to do it from, let's say, a 10K, 20K long case to summarize it to a few hundred words. That's the difficulty here. And the other task includes like argumentation mining, named entity recognition. And the classic one is the legal judgment prediction. So what is legal judgment prediction? That's what we do in That's basically what do in our work here. It's a joint work with Santosh, the other PhD student at our chair, and Oana. She is our legal expert at the European Court of Human Rights, and Professor Matthias Krabmeier. So first, I will introduce you what is LJP, legal judgment prediction. So in mainstream NLP, basically, you can define it as a classification task. The input is the case fact and the output is the case outcome. And it's gaining more and more attention in legal and mainstream NLP communities. And in different courts, different countries, honestly, the performance is quite well. In some data sets, it gets even a micro F1 of like 0.8 or something. That's actually quite good. So the question is, are we going to have a robot judge? The answer is no. We have to point out the risks here. So as already demonstrated in the previous work in mainstream NLP, the deep neural models tend to exploit spurious tokens and take spurious patterns and take shortcuts. Spurious here we mean is like statistically predictive, but legally irrelevant. And the problem is in legal domain, the case facts are often drafted after the case outcome are already known, and it leads to many confounding effects. And in such a high-stake domain legal, this can pose risks and lead to undesirable consequences. For example, the model might rely on data which is statistically predictive but legally irrelevant or even forbidden. For example, the protected attributes like race, gender, or country of the accused person. So in our work, instead of focusing on improving the prediction performance, we choose to focus on how to improve the alignment between legal experts and the LJP models. Because we think it is important in the future, if any legal decisions are to be predicted by such kind of a system, and this kind of system must strive to be as closely as possible aligned with legal experts. So that's what we did in our work. First, we introduced the expert-informed deconfounding method to identify the superior signals, which includes like respondent country, length of the document, and the superior tokens. And we mitigate them through adversarial training. We evaluate our deconfounding method using explainability techniques. We work on the European Court of Human Rights data set. And we found our results show that our models, deconfounded models, consistently aligns better with experts' rationals than baselines. And we also publish our data set of the annotated golden rationals to facilitate any future research in this direction. And okay, so here's the data set we worked on. We merged a few public available data sets on the European Court of Human Rights, and we worked on 4 different tasks. So here, I want to introduce you the process in the ECHR court. So first is the applicants make allegation, accuse which articles are allegedly violated. So that's our task B. It's a multi-label task. The input is the case fact, and the output is the which specific articles are allegedly violated. And then the court makes decision. That's our task A. Input is the case fact. Output is which specific articles are actually violated here. And then if we binarize task A, then we got task J. J for judgment. It's a binary classification task. And we propose the 4th task here, task A given B, where the input is the case fact as well as the allegations, and the output is the violation. We think this is more reflect more the reality in the legal process, because the court is always aware of the allegation when deciding the case. And here I'm going to show you the superiorist attributes we found in the data set. So first is the paragraph number. So we found around 70% of the non-violation cases in task J are inadmissible cases. But legally, inadmissible cases are not necessarily non-violation case. So inadmissibility means this case does not fulfill the court's formal or procedural criteria. For example, the case is filed outside of a time limit or something like that. So in this case, the court does not examine the merits of this case at all. So to give an example, this is admissible but not violated case. So it's admissible, so it's examined by it has been examined by the court. So there is this procedure section first, and then the facts section follows. So we can see the first paragraph number appear in the facts section is 8. While in the inadmissible case, because it's inadmissible, so it's not examined, so there is no procedure section. So the first paragraph number appears is 1. And usually this paragraph is about the background knowledge, background information of the applicant. The second superiorist attribute we found here is the document length. As I just mentioned, 70% of the non-violation cases are inadmissible. And those inadmissible cases are not examined by the court. So the register of those cases tend to just draft them rather shortly. That's also I mentioned before, because the case facts are drafted often after the case outcome is known. So we can see here the non-violation case, the average length of it is shorter than the violation cases. Another superiorist attributes is the respondent state or countries. Some countries just tend to have more allegations under some articles. So that's these 3 attributes: paragraph number, document length, and the countries. They are implicit in the documents. But here we found also some explicit superiorist signals, for example, tokens. We found actually, if you just insert the word represented to a violation case, it's basically a natural, how do you say, it can flip all the violation case to non-violation case. So it's a very, very strong superiorist signal here. But how to automatically detect all the other distracting or superiorist tokens, that's our expert-informed method here. So the method is actually quite easy. We use a depth limit decision tree using an n-gram trained on the main outcome prediction task. And then we extract all the top nodes tokens from the tree and filter the tokens using LMI to identify the predictive tokens and iterate this process. And then we present the list of removed tokens to a legal expert. And the expert categorizes them into superiorist or legally relevant for our target variable. And here's an example of the superiorist vocabulary we found in task J. So as we can see here, it's like represented and national minister, which is often can be found in the first paragraph of the inadmissible cases. So these words are often, we can say it's associated with the applicant's background information, but it's not associated with the violation. So that's why it is regarded as legally irrelevant here. Okay, so that's what I've just talked about, those attributes, superiorist attributes. We have found them, and the question now is how to deconfound them. Our method here is using adversarial training. So basically, assume we have our model, the input is the case facts, and then we have feature extractor to got the document representation, and then we feed it to a label classifier, and then we got the final case outcome output. And in parallel to it, we have a discriminator for each of those superior attributes we just mentioned, together with the GRL, gradient reversal layer. So the idea of a gradient reversal layer is like, in the forward path, the discriminator learns to maximize its ability to detect those superior information. But at the backward path, the gradient is negated or reversed by a negative lambda, which minimizes the feature extractor's ability to capture those superior information. So in all, we can see in our method, it's like the upper branch, which we want the model to maximize its ability to get information for the violation, case outcome violation. While in the lower branch, we try to distract the model from all these superior signals. So we hope this method can help the model to rely on the information or the representation in the document which is legally relevant, rather than those superior signals which is legally irrelevant. And here's more details on our models, and I will introduce more terminology to help you to understand it. So first is our baseline model. So the input is case facts, and then you go through a feature extractor and then to a classifier. The feature extractor we use here is a hierarchical attention model because the text is too long. I think averagely it's like 10K. So a normal bird cannot handle it. So for it, we extract the token level embedding from legal bird, and then use a token level attention layer to aggregate to get a sentence level representation, and then aggregate it again to get the document level representation. And then we have our paragraph removed model, which is actually the model structure is the same as our baseline model. The difference is the input text. In the pipeline, we just first removed all the paragraph number in the text. Because we mentioned the text, we regard paragraph number as a signal, superior signal. And then these are our deconfounding models. Gradient country means apart from the normal classifier, we have a country discriminator, which is a multi-class. So we have 46 different countries. And that's the document length deconfounding model. So we bin the length of each document to 4 bins. So it's also a 4 classes head. And then we have a grade vocab. It's also a multi-label head because each case can have multiple superior tokens in it. And finally, it's the gradient, or it's the deconfounding. We combine just these 3 components together. And here's our metrics. For the main case outcome prediction task, we just use F1 as showed here. We focus on the expert's alignment performance. So here we try to identify the correct irrational at the paragraph level, which is the natural granularity of the ECHR fact sections. And how to calculate the scores? First, we use integrated gradients to obtain the token level focus score. And then we aggregate them to paragraph level using squared L2 norm and penalize it by the length. And we measured precision at Oracle, where Oracle is the number of relevant paragraphs in golden rations for the instance. So here's the results. First, we compare the paragraph remove model with our baseline. As we can see here, the paragraph remove model performs consistently better because we think the paragraph number is just such a obvious superior signal. So the model got stuck at the local optimal. And then when you remove it, it helps the model to learn more the real legal rationale here. And then here's our results of our deconfounded free individual deconfounded model with paragraph remove. As we can see, this deconfounded model performs consistently better. But if you look at a little bit into details, we can find generally the vocabulary deconfounded model performs the best, except in task B, which is the allegation prediction task. But this is consistent to our initial experiment in decision tree, because in other tasks, for example, in task J, we can observe a clear, obvious drop of the performance when we remove a few spurious tokens. However, this drop does not exist. It's not so obvious in task B. The hypothesis is the nature of the task B is allegation prediction. It's actually very similar to topic classification task. So there are just too many topical words to focus on. Even you remove a little bit some from it, the model can focus on the other. So that's why in this task B, the length grade deconfounded model performs better than the vocabulary deconfounded model. And finally is our grade odds. We combine all three individual components together, and it performs the best. So we think that shows the complementarity between these three confounders. And here is the performance of the main case outcome prediction. As we can see here, we don't see a clear big drop off on the main prediction task. So we can say here is our deconfounded model achieves to help the model align better with the legal experts. In the meantime, there is no big drop in the main prediction task. And we also did qualitative evaluation on the rational markup. So we asked our legal experts to rate the rational markup into metrics. One is sufficiency and one is relevance. And as we can see, our grade or deconfounded or model performs consistent better than the baseline paragraph removed model. And we also manually inspected a few case markups. And we find that interestingly, very interesting, it's deconfounding model tends to redistribute its focus to larger text segment, which makes the markup more dense. And we find interesting the paragraph remove model focus on the unigrams, which is the nodes in decision trees, which means no matter how complicated those deep neural networks are, they easily fall into those easy superior signal tokens. And we found that what's also interesting is the paragraph remove model seems to focus on the beginning of the sentence, which means it is trying to count the sentence, which justify why we deconfound the length of the documents. And yeah, here's some final takeaways. So yeah, as we show here, though the current LJP system or deep neural models performs quite well at legal judgment prediction task, but the system is vulnerable to distractors, to spurious signals. And our method, the expert-guided adversarial deconfounding, can mitigate this problem, improve its alignment with the experts in the meantime without big drop in the main prediction task. But we have to admit that the alignment score is still limited. So we hope our work can attract more attention in this direction, and promising future direction can be how to find more efficient way to find more subtle distractors. And the other way, it's a long way to go. I think my takeaway is like we should work more closely with legal experts and to think how to really bring real legal knowledge to the system and to create a more trustworthy, robust legal judgment prediction system in the future. Okay, so that's it from my side. I'm happy to take questions now.
Thank you, Shanshan. This was very interesting. I have a few questions. The first question is about how do you pick out the metrics for the different tasks? So for example, the macro F1 and so on. How did you decide on the different metrics?
Okay, so the metrics. Okay, you mean here, right?
Yes.
Yes. Okay, right. Let me have a look here. Okay, so task J is a binary classification, so we just use the macro one. And for the other one, they are basically they are multi-label. Yes, multi-label classification tasks. So it's very important to see both micro and the macro F1 here. And for task A and task A given B, yeah, I think the problem is also, yeah, the important is the label class distribution is very imbalanced. So it's very important we also calculate the macro F1 here.
I see.
But I want to say our focus here is not the prediction task performance. We focus more on the alignment with the expert.
Yeah. Maybe before anyone else, if anyone else wants to ask any questions, I have just like a general question about what you think is going to happen. I mean, obviously, this cute clickbaity title of the robot judge is,
Yes.
is funny. I like it, but your actual work is impressive and is very interesting. But I'm wondering, because every kind of technology first gets this hype, and
Yes.
then we get grounded, we get slammed to the floor, and we're like, okay, let's look realistically. But especially in this domain, it's generally very interesting subject, and I'm wondering what kind of, I mean, you talked about it. I think it was in slide number 15 about what you're not trying to do and what you're trying to do.
Okay,
So,
yeah, here.
Yeah, the Drake meme. I was thinking, what is something that is high quality and that, for example, legal experts might use in some near future that is actually usable with LegalTech technology? It might be really interesting. Yeah.
Thank you very much. Very interesting question. I think let me put in the other way. What is not going to be used, I think, is the LJP system, legal judgment prediction system. Because first, it's very high stake. There's a lot of legal consequence here. And second, we can see that's just a lot of the current system is more like a black box here, and we cannot afford a machine to a black box model in our legal decision process. So I think what can be useful is rather like here is like legal case retrieval. Because lawyer in their daily life, they need to work a lot on citations or especially in case laws to refer to find cases like this, because they want the lawyer needs to find a case where meets all the requirements here. So in this kind of like, I think it's more doable in the future. It's a case retrieval task. And actually many industry company, they have their technologies. There are a lot of legal tech companies. They are offering this kind of services and they are doing, of course, better and better. They used to do with maybe like using embeddings. And nowadays, they're also, I think some companies are also using ChatGPT in this kind of tasks. So I think that's what I think is in legal tech. So I think for academia, of course, LGP such a task is interesting because it's a classification task and sounds cool because it's predict the case outcome. But I think it's much more like a toy task for the computer scientists. For lawyer, I think it would be more interesting to see how to help the lawyer works better, works more efficient in their life. That's what I think. I think in our participants in our audience, I see someone from the legal domain who was at least a lawyer. So if you are interested, please I want to hear your opinion on all the latest technology in the legal domain. Yeah. Hi, Sebastian. How are you?
Thanks for calling me out. I have to work.
I'm sorry, I cannot hear you.
Oh, you cannot hear me?
No, it's better.
Yes,
okay.
Perfectly.
Okay, amazing. So I also doing a PhD at TUM, but I'm a lawyer, so I'm doing legal tech from the other side. And if I'm called out, I will just give my 2 cents about it. So there's 2 major things that we look at from our big law perspective, where we also apply this. One of them, of course, being we toy around, especially since GPT-4 was in the API with generative AI, which is working surprisingly well. Nothing we are really using just because of liability issues, as the interpretability or explainability issues are still a killer for us. However, what we really use as of right now, and what is going quite well, is classification tasks, as we face very huge amounts of data from our clients that need legal expert knowledge as of right now. So models like BERT, for example, I mean, of course, we know the restriction of the 500 tokens, but the general idea behind that is something that we actually use as of right now in practice, and that is proving to us to be really efficient, also from a lawyer's side. These are just 2 things that are really hot for us right now. Of course, we keep an eye out for everything that's happening on the side, but these would be the 2 takeaways, if that is the input you want, Shanshan.
Yeah, I want to follow up, like classification. How do you cope with the 500 token limit first, and what kind of classification I do is like not case outcome, but rather like topic or?
Yes, I can only be on a very high level there, just because this is a project that I work on myself, and I am bound to not say anything more. But it is identify the general topic that this is about. That is there a specific semantic thing that is in the text, for example?
Okay, cool. Thank you.
This is. Thank you very much for your input. This was very interactive and interesting. Thank you both for that.
Sure. Thanks for calling me out.
Thank you.
We have a question from iPhone in the chat, and oh no, actually we have another question. Taking inspiration from ChatGPT, can you imagine reinforcement learning being used in this task for better alignment with experts?
Yeah, of course. But the first problem is, of course, the limit, input limit. So ChatGPT can take only 4K, but the legal text can easily be over 10K. But GPT-4 can take now, I think, up to 32K now. So I'm very excited to see there must be some new improvement here. And also, in GPT-4's paper, I think they released their latest performance in the American bar exam. The performance is actually quite good. So I think reinforcement learning is definitely going to play a role here, especially maybe in legal reasoning, rational. That's must be very interesting.
Yeah, what you mentioned was one of the few informations we got from the paper.
Yeah.
Good that we got something, yes. But iPhone is asking, what is your opinion on donotpay.com, world's first robot lawyer? In case you have heard of it. I have actually not heard of it, so I have to look into it.
Yeah, I haven't heard about it.
To avoid dead air, I actually have another question that I thought about during your talk. It's if in case Sebastian is still here, I would like to hear both of your inputs, and it's more of a social perspective. So what you're talking about in your paper is very much from the perspective of the legal system and lawyers, and yeah, so it's the other side basically. I'm thinking, is it possible to actually benefit people, kind of, because obviously if lawyers are trained to know how to search for specific laws, but what they need in their day-to-day work is to retrieve cases. So I'm thinking people that need legal help and, for example, cannot afford it. Do you think there is a possibility to help these people in some future, just by giving them access, just even access to even research on themselves? Yeah.
Sure, definitely. I think I just take a short look at the robot judge or donotpay.com. I think that's some similar service, which you upload all your files, and it gives you a first step, like advice whether how you can proceed your case. And I was at the Munich LegalTech collab. They have some startup companies in LegalTech also work on the same direction, helps people without legal background knowledge to see how can you get your, I don't know what's that, I forgot some legal laws, like to protect maybe consumers, or just, I think as you mentioned, lawyers are expensive, and if we can make it more like scalable, like available to normal person, that's definitely a social good thing. But however, we need to balance like the precision and recall. So, and also if you give a legal service, you need to take, of course, the legal consequence, and how to solve all this problem is, of course, important.
Yeah, that's true. Yeah, thank you for the answer. Also, I don't know if you
sorry, I just heard you wanted my input there as well. I don't want to.
Sure, of course.
Go over. No, I don't want to like step ahead if I don't have to. But just the insight from the lawyer perspective, that is of course the goal that we follow with LegalTech from like university side, is to make things more affordable. A good lawyer takes roughly 300 to like 600 euros per hour. And that is, of course, something that you could not afford, especially if you know the opposite side has it and you don't. This is, of course, a double-edged sword, as development of good legal technology requires money. And it is rare to have legal technology be open source, although I wish it was more. And also what Shanshan mentioned is, of course, the right step into that direction. However, there is also a high chance of this being a digital market. It creates monopolies, and it allows the ones who are able to build it to actually scale up and then get the others out of the market. So, of course, there is a potential, especially with the very quick advances in the technology that also set the ones very far behind that have been investing in it. So there's an even playing field as of right now, or a more even playing field. But there is chances and risks at the same time. I think, I hope this makes the access to justice better. I am not 100% sure if it really does.
It's a tricky issue also with ChatGPT. I don't know if you saw it, but very specific. I mean, especially with justice, it's especially sensitive and important to be really careful. For example, with ChatGPT, I think I read an article, I think last week, and it was about how many different, very specific things and company secrets have been leaked because people from consultant companies basically just without any censorship just put the entire project details of confidential data in ChatGPT, and ChatGPT of course doesn't care and just spits them out at people who want to retrieve them. So this has happened, and right now it has been 100% banned in many. I think in Deloitte.
Is it like that though? I thought if you had like the Azure API subscription, your data would be protected. I thought this is what everyone aims for.
It has nothing to do with professionalism. Like what you're thinking about is very professional. It's just, for example, you have a presentation in 2 hours and you want to do your presentation, and you just ask ChatGPT on your personal browser for some tips, and you include very personal details about the project in ChatGPT. It has nothing to do with APIs. Just open a browser and just type in company secrets. Yeah.
Yeah, that's very true. I have a consultant friend told me basically the same thing, and actually they kind of give up using the Google search now. They just ask ChatGPT or like the new Bing, like tell me the revenue of the company, something, and it works quite well. And actually, I think not only like I would say, in the yesterday, it's like a linguist who has like anxiety to be fired, right, because of the development of NLP. But nowadays, programs or even consultants have this kind of anxiety. So the field is just developing too fast.
I can also tell you that this is also lawyers being scared of being fired as of right now. The advancement between GPT 3.5 as base of ChatGPT and the 4 version is immense. And looking at what this is from a legal standpoint, it's really scary.
Yeah, but as I just showed, if you look deep into it, I think you're sure you can find some hallucination parts that are just ridiculous, not making sense.
Yes, this is true. But I have been doing like a lot of tests on the classic ChatGPT, so GPT 3.5, and I could clearly tell all the hallucinations and all the bullshit that was going on. And for the latest version, it's getting way trickier. It is way better at even fooling experts in the field. Of course, it's still bullshit, I must admit, but it's way harder to figure out what if that is bullshit.
Good to know. Yeah.
I don't know how you feel about this. Do you feel scared?
Of course, I'm scared. Like I was a linguist. I thought I made the right decision to come to NLP, and now I'm like feared again.
Same. It's running after us, and it's trying to catch us. So yeah, I think on the positive side, I don't actually realistically think that legal professionals are actually going to be out of work anytime soon, because the stakes are so high that the system is not going to allow it itself. And at least I hope so. And this is my optimism in this case. I'm usually somewhat of a realist or pessimist, but in the legal case, I feel, this is just my personal opinion, like this is not something for now we have to worry about. But I think at least law students' lives are going to be much easier in the future with retrieval and this kind of technology. Maybe even help them be better lawyers. Just on the optimistic side of views.
Yeah, but I feel like it's more like the low-level work, the paralegal, or that's going to be maybe more easily be replaced, as we can see models can do it quite well in the case recommendation or easy classification task. So that's what I think.
I would like to welcome everyone that still has any questions to ask them, and if not, I would like to thank Shanshan for her interesting talk. We are going to upload this to YouTube, so you can watch it there. Also, thanks for Sebastian's input, and and see you next week and the week after that.
Yeah, thanks a lot. Thanks for the questions here. Very nice discussion.
By the way, just a random thought. because you mentioned the paralegal work, I was thinking in case, so this type of paralegal work and kind of internship level, low-level work is how a lot of people get their foot in the industry. So obviously this is not something you can, I mean, the growth curve in the software development industry, for example, is very steep. You can be a junior now and a senior in 2 years, but in the legal system, it doesn't work like this. So I'm thinking if it maybe in some cases it would make this type of work more exclusive, because if a lot of the paralegal work is automated, many people then don't have any connections, are not actually going to be able to get their foot in the industry and just be left out. So this is just something I spontaneously thought about. Yeah.
I think you're right, but also at the same time, old jobs will be replaced by new jobs. I guess there will be a lot of jobs for prompting engineer. So in legal domain, we definitely need someone with good background knowledge to make good prompts.
It's just going to force us all to be very qualified or more qualified. But
yeah.
Just that. Yeah, thank you. As I said, very interesting. Thank you all for coming. Thank you for the questions, and see you next week. Thank you, Shanshan.
Okay, see you. Thank you. Thanks for having me here. See you. Have a good evening. Bye.